Welcome to Monochemistry. Today I'm going to introduce you to the concept of chemical equilibrium. A chemical equilibrium is achieved when the rates of both the forward and reverse reactions are equal or constant. It also means that the concentrations of the products and reactants will remain unchanged over time. Chemical equilibrium is denoted by a double arrow. Now let me show you what it will actually look like in real life. I don't have a way to create equations in this program that allow it to work out properly. So you see this double arrow here actually simply means reversible. Equilibrium is actually denoted by a double arrow like so. Okay, so this one here, this one means reversible, and this one means equilibrium. But for our intents and purposes in this course, because I can't create equations on my program here that have this type of arrow, we're going to use this as being equilibrium. But when you write it, you should write it like this. Okay. Here we have a graph of reactants and products. You should be able to identify the reactants and the products. Reactants, of course, are going to decrease in concentration over time. Products, of course, will increase in concentration over time. I want you to draw a little graph in your notes, and I want you to determine the point at which equilibrium is reached. Look back at the definition that I gave you, and I want you to draw a line on your sheet here once you've copied this graph. It doesn't have to be perfect. And I want you to identify the area where you think, or the line in which you think, equilibrium has been reached. And make sure you bring that to class with you. Okay, so equilibrium expressions. Equilibrium expressions are essentially the constants that go along with these equilibrium reactions. So let's talk a little bit about this reaction here. So we have simply A plus B yields C plus D. And of course there's coefficients, little a, little b, little c, little d. Now for this course, we often interchange some of these things. So KEQ literally stands for equilibrium constant. Most of the time, that KEQ is going to be equal to the Kc. The Kc is simply the equilibrium concentration with, equilibrium constant with respect to concentration. And the Kp is simply the equilibrium constant with respect to pressure. Now Kc only takes into account aqueous solutions. It does not take into account solids or liquids. And Kp only takes into account gases. It does not take into account anything else. And I should actually go back to Kc for a second. Kc can also be used, because you can have a concentration of a gas, Kc can also be used for gases. So gases and aqueous solutions for this one, only gases for this one, and it's specifically dealing with pressures. Okay, so if this was my equation, if this was my chemical reaction, my Kc would be equal to this as follows. C raised to the power of C, D raised to the power of D, the concentrations of, divided by the concentration of A raised to the power of A, the concentration of B raised to the power of B. That's it. That's how you do it. Don't make it more complicated than it is. Whatever the number is out here, that's the number that goes there. If it's a 1, great. Whatever the number is here, that's what goes there. Okay? Now for Kp, it's the same thing, only we're dealing with partial pressures. So whatever the partial pressure of C is, raised to the little c power, whatever the partial pressure of D is. Okay? So it's essentially multiply these two together, multiply those two together, and then of course the reactants are being divided into the products. Products, concentrations of the products divided by the concentrations of the reactants, or the partial pressure of the products divided by the partial pressure of the reactants. That's it. It's as simple as it gets. Now I want you to try. I want you to pretend for a second that this reaction, oh, I didn't draw my arrow properly. There we go. This reaction here, I want you to write the Kc expression for. And this reaction here, I want you to do the Kp expression for. I want you to do both of those using the equations there. So this is I want you to do Kc for this one, and I want you to do the Kp for this one. That in a nutshell is your introduction to chemical equilibrium and how to write an equilibrium expression. Make sure you bring your questions, any questions you have on this to class, but also make sure you bring your answers so we can check them.